Okay, this is an experiment, literally for an experiment for an experiment. We're gonna. I'm trying it this way to try to explain the lab that we're going to be doing to measure the speed of sound. Trying to show you this so that you get a chance to look at it hopefully beforehand, and so that what I have here is the front page of the procedure. On the other side is the back page of the procedure, or the data table. I want to talk about both parts. I still want you to read the procedure. Watching this video is not a substitution for not reading the procedure, because there's a lot of information here that gets into all the details that I'm not going to talk about in this little short video clip. This lab is on measuring the speed of sound using standing waves. We're going to generate standing waves in a tube, and we call that tube a resonance tube. We're going to use some tuning forks in order to do that. One of the things that you need, some of the equipment that you need to get, you obviously need to get the resonance tube. I'm going to show you that in a minute. But you need to get 5 tuning forks. One of the tuning forks has a piece of tape on them. That's an unknown. You're going to use this one last. The other 4 tuning forks, and you've probably seen a tuning fork before, you need to get 4 different size tuning forks. And what I want you to do, and when you do the lab, you're going to do them in order from smallest to largest. So of my 4 forks, this one's the smallest. I'm going to use the first trial. I'm going to start with this tuning fork. Now, the resonance tube that I'm going to use consists of a clear plastic tube with a white PVC tube inside. On the white PVC tube, there's a measuring tape attached to it so that we can measure. I already have it filled full of water. It's what I did was I took the white tube out, filled it about halfway full of water. I put the white tube in, and then I filled it up maybe about a little less than an inch short of the top with water. I need a lot of water in here. Obviously, overflowing is stupid, and you're going to spend time cleaning things up. The first thing I'm going to do is, and the whole purpose of this is to use this tube to try and recreate these standing waves. First harmonic, second harmonic, third harmonic, fourth harmonic if it'll fit, if there's enough room, if the tube is long enough. And the way that I'm going to do that, I'm going to use a tuning fork. And the process is to take the tuning fork, I'm going to strike it, and when I say strike it, I typically use the heel of my foot. I don't want to hit it on anything hard like the tabletop, the bench top, my head, because it might damage the tuning fork. So I'm going to strike it, I'm going to get a good sound, I'm going to hold the tuning fork over the tube, and I'm going to slowly pull the tube out. And what I'm listening for a change in volume. Because when I hit the standing wave and I have constructive interference going on, the sound is going to be louder. The first time you try and find it is a little bit hard to do. But after you get it the first time and you know what to listen for, it makes things a little bit easier. So again, here's the basic process. Right about there, I heard it. I'm hearing the tuning fork sound, but as I'm lifting the pipe out, and I got to keep my ear right over the pipe, right around here, it got a lot louder. But that's the basic idea. When I find that loud spot, I'm going to record the height, and this is right at 15 centimeters. All right. So what I want to do, I'm going to go to my data sheet. Fork number 1, position number 1, my first position, 15 centimeters. I want to record that as meters, 0.15. The other thing I need to record the frequency of my fork. Printed right on the side of the fork, and this is 512 hertz. Now I'm going to repeat the process. This line was right about at 15 centimeters. I'm going to repeat the process to find the next node, which is going to be further on down. I can estimate where it's going to be. This is 1/4 of a wavelength. The nodes occur every half wavelength. So if I take 15 times 3, this is in the procedure, 45, my second node should be around 45 centimeters. So I'm going to go ahead, I take the tube out until the water level in the tube is around 41 centimeters. I don't want to go much more than that in case I miss it. This estimate isn't perfect, it's just to give me a ballpark idea. I'm going to repeat the process. Strike the tuning fork, hold it over, listen for that loud spot. You've probably already noticed it's getting kind of high for at least me, and your ear really has to be over that tube to be able to hear it. You might need to stand on a desk, you might need to sit on the laptop, that's okay in order to get the right measurement. Let's see if I can't, if I'm not tall enough to do this now. If I don't fall down either. That wasn't good. Not quite hearing it. Let me try one more time. There it is. Got it. Perfect. It's at 48 centimeters. I estimated 45. I knew it wasn't perfect. 48 centimeters, that sounds pretty close. So I'm going to go to my second position. My second position, I'm going to write in 0.48 centimeters. I'm going to keep repeating this process for my third position, hopefully for my fourth position. I'm going to keep repeating it until the tube is out of the water. I'm not going to always get 4 positions, but I'm going to at least get 2 positions. I'm not going to do those parts right now. I want to show you some of the math that's involved. So, the next step, once we fill in these gaps, if we have them filled in, I go to my next row. And what this says is second minus first. And what I'm going to do is I'm going to take my second position minus my first position. 0.48 minus 0.15. That's 0.33 meters. I'm going to take my third position minus my second position, and I put that value right in here. And I'm going to do that for as much as I can. After I get this calculated, hopefully I get a number there. With a little bit of luck, I get a number there. I want to take the average. I might be averaging 3 numbers. I might be averaging only 2. I might only have 1 number. In this case, I'm just going to work with this number. And when I average 0.33, I get 0.33. This number represents half a wavelength. That's what this lambda over 2 means. This average number is half a wavelength. So my full wavelength is twice this, 0.66. My next calculation is to calculate the speed of sound. Now, velocity, and we talked about this in class, velocity is wavelength times frequency. I have a wavelength. Here's my frequency. I should be able to calculate the velocity of this. So I'm going to take 0.33, and since that's half a wavelength, I'm going to multiply times 2. And then I'm going to multiply times my frequency, which is 512 in this case. I do this math, 0.33 times 2 times 512, and I get 338 meters per second. At this point, I'm done using this tuning fork. I'm going to get my next larger tuning fork. I'm going to repeat the entire process. Get a calculated value for my speed of sound, for my velocity of sound. I'm going to do this for all 4 tuning forks that I have the frequency for. Once I have my 4 forks done, I want to calculate my average velocity. That's the average of my 4 results. That number goes into here. And I'm just going to use my one number that I have so far, 338 meters per second. Finally, the 5th fork. The last fork, the 5th fork, is my unknown. I have a piece of tape over it. On this fork, there's a number 5 written on the tape. So I'm going to record that number. I'm going to record it right here beside the table. I want to know which unknown fork you have. 1, 2, 3, 4, 5, 6, 7, whatever. So that I want to compare the value you got to the actual value. Same process. I'm going to take my resonance tube, strike my fork, raise the pipe out of the water. I'm looking for these nodes. I'm going to do the same process to calculate the average value here, the average half wavelength. However, I'm not going to calculate the speed of sound for this tuning fork. I'm going to calculate its frequency. If I know that half wavelength, using my average velocity of sound from my other trials, I can calculate the frequency of this fork. Frequency is velocity divided by wavelength. So I'm going to take, in this case, 338 divided by whatever number I get there. But remember, I've got to multiply that by 2. This is half a wavelength. That gives me my value of my unknown frequency. So record that frequency in there. The final part, I want you to calculate a percent error. The percent error is based on the speed of sound. I'm going to measure the temperature in the room, and I'll tell you it's like maybe 21 degrees Celsius. Here's the calculation for the actual speed of sound. I want you to calculate what the speed of sound in the air actually is. This is an experimental speed of sound that you determine in your lab. The percent error calculation is, and you should know it, actual minus experimental absolute value of that divided by actual. Can't spell. It's late. Times 100. If you're careful when you're doing this lab, you should have a pretty small percent error, 5%, 10%. It should be pretty small. That's the lab. That's measuring the speed of sound lab. When you're all done, I want you to dump the water out of the tube. Please be careful doing this. Pour it slowly. It can gush out. Just pour it out slowly. Don't try and dump it all out at one time. Make sure all the water is dried up and cleaned up everywhere. And I need the data sheet for everybody. So keep it clean, keep it neat. Reminder, don't forget to read the procedure. You still have to read the procedure. There's a lot of information I skipped over because it's in the procedure. Hopefully this lab will work out pretty well. If you watch this, feel free to download it to your phone, iPod, whatever, bring it to class so that you can refer to it while you're actually doing the lab. But as I'm lifting the pipe out, and I got to keep my ear right over the pipe, right around here, it got a lot louder. It went, a little bit, not that weird, but okay, that was kind of stupid. But anyway, it is to reproduce this in a lab, and what we're going to use is this pipe with this inner, yikes, that was my bad, with this inner PVC pipe. You're going to take a little bit of water. This is the pipe is closed on the one end. We're going to take some water and fill it up. And it drips all over the place.